Hi, everybody, and welcome to Dr. Archer's Lectures. For the past couple of weeks, we've been talking about supply and demand. This week, we're going to really focus in on that demand piece of it as we tackle the concept of elasticity of demand. But before we go there, let's review real quick to make sure that we're very, very clear on the law of demand. The law of demand says as price goes up, quantity demanded goes down. It's the law. It always works this way. Price up, quantity down. Price is what drives the bus. If you want to change the quantity demanded, the only way to do that is to change the price. When the price changes, then the quantity changes. Price is the one driving the bus. That's a great law. If price goes up, quantity demanded goes down. But if I'm running a company and I'm thinking of taking a price increase, the obvious question to me is, how much? If I'm thinking of taking a 10% price increase, how much of my quantity am I going to lose? If I raise the price 10% and I only lose 1% of my quantity, no sweat. If I increase my price by 10% and I lose 50% of my quantity, that's a big problem. So we need more complete information, and that's what price elasticity of demand is all about. This is a model for calculating how much quantity will change in response to a change in price. And we calculate it by taking the percentage change in quantity and dividing by the percentage change in price. It tells us how much quantity changes in response to a change in price, just how price sensitive are our buyers. So let's take a look at one of these problems. In the first one, I make it easy. I tell you exactly what the percentage change in price is. We have it right here. Price changes by 10%. It's going up. And how much quantity changes right here. Quantity is going down by 15%. So if price is up by 10 and quantity is down by 15, our price elasticity of demand looks like this. Percentage change in quantity, 15, divided by percentage change in price, 10. 15 divided by 10 equals 1.5. Easy schmeezy. Few things to notice about this. First of all, this formula calls for percentage change in quantity divided by percentage change in price. So we don't have to convert these to decimals or anything. You can just put 15 divided by 10 and come up with 1.5. That's all well and good. The second thing is, remember that as price goes up, quantity demanded goes down. They're moving in opposite directions. So you're always going to get one positive number and one negative number. If price is positive, then quantity will be negative. If price is negative, then quantity will be positive. Given that, you're always going to end up with a negative result here. And so to simplify the calculation, we just drop the negative sign. We just report this in absolute values. So this is 1.5, even though it's a negative 15% divided by a positive 10%. It's just 1.5. Third thing to notice, price elasticity of demand is just a number. It's not a percentage. We don't convert it at all. We just leave it just like we calculate it, 1.5. What this 1.5 tells us is every time the price goes up by 1%, the quantity is going to go up by 1.5%. That's the ratio of the two. So here, when the price went up by 10, quantity went down by 15. If the price goes up by 1, quantity will go down by 1.5. Last thing to notice over here on this demand curve, this is a familiar area. Remember that we have price on the vertical axis and quantity on the horizontal axis. Because of that, and because quantity is changing greater, the change in quantity is greater, we're getting more movement along this horizontal axis. Our demand curve is kind of horizontal. It's a little flat here. That's because change in quantity, the horizontal axis, is greater than change in price. This is all well and good, but this is an easy problem from the standpoint of I gave you the percentage change in quantity and the percentage change in price. Under normal circumstances, this would never, hardly ever be the case. In the real world, you would have to do this in 3 steps. You would have to calculate the percentage change in quantity and calculate the percentage change in price, and then use those 2 numbers to calculate elasticity. So that's where we're going next. Remember from your high school math classes that when you calculate percentage change, you take the ending value minus the starting value and you divide by the starting value, or at least that's the way we did it in high school math classes. We're not going to do it that way here. I have another way. There's a problem with this here, and the problem is this is going to give us a different result if the price is increasing from the result when the price is decreasing. Let's run through that math real quick. Using this old formula, which we're not going to use, but just to look at it here. If we go from A to B, 250 is the end value, 200 is the start value, 250 minus 200, divided by the start value, 200, you get a change in price of 25%. But if we go from B to A, we get a different percentage change in price. When we go from 200 down to 250, it's still $50 difference, but now we're going to divide by $250, the starting value, so now we only get a 20% change in price. That's just never going to do. We need something that's going to give us the same stable percentage change in price, whether price is increasing or decreasing. And that's why we turn to the midpoint formula. And this, by the way, is how we're always going to calculate percentage change in price or quantity for all of our elasticity problems. It goes like this. Instead of dividing by the starting value, we're going to divide by a number halfway between the starting value and the ending value. We're going to split the difference. So when we go back to that percentage change in price that we just calculated, if we're going from 200 to 250, we have 250 minus 200, which is $50, divided by 225, the number that's halfway between 200 and 250. And that gives us a percentage change in price of 22.2. What if we're going the other way? What if we started at 250 and we're dropping the price back to 200? Then you would get 200 minus 250, a $50 change. You're still going to divide by this number halfway between the 2 numbers. So you're still going to divide by 225, and you're still going to come up with 22.2% change in price. A nice, stable percentage change in price. That's exactly what we need in order to get good numbers for our elasticity. We're going to do the same thing on the quantity side. If we move from the high price to the low price, 12 minus 8 divided by a number halfway between 10. 12 minus 8 divided by 10 gives us a 40% change in quantity. A quantity of 12 minus a quantity of 8 divided by a quantity of 10. If we're going the other way, if it's 8 minus 12, we still get 4. Divided by 10, we still get 40%. So with those good stable percentage change numbers, we can easily calculate our price elasticity of demand. We're going to take change in quantity demanded, which is always going to be 40%, whether we're moving up the scale or down the scale, and our percentage change divided by our percentage change in price, which is always going to be 22.2%, whether the price is going up or down, and we're going to get an elasticity of 1.8. 1.8. Always 1.8. What makes something more elastic or more inelastic? There are some determinants, some factors that make a product tend to be more elastic or tend to be more inelastic. Elastic meaning very price sensitive, inelastic meaning not so price sensitive. But before we even talk about this, I want to encourage you to get rid of the idea, just wipe it out of your brain, that some products are elastic and some products are inelastic. That's not the case. All products tend to be inelastic, not too price sensitive at low prices. But as the price gets higher, people get more and more price sensitive until demand ultimately becomes elastic. It's true for every product. The question is, do they tend to stay inelastic longer, or do they turn elastic very quickly? And that's what these determinants tell us. So let's take a look at them. If there are a lot of close substitutes, if I have other things that I can buy, I'm going to be much more price sensitive on that product. Price sensitivity means this is going to stay elastic or inelastic for a very short period of time. At a very, very low price, it's going to get price sensitive. It's going to get elastic. Is this product a necessity or a luxury? If it's a necessity, that suggests that I have to buy it, at least until I figure out an alternative. So that's not going to be very price sensitive, and it's going to tend to stay inelastic for a longer, a wider range of prices. If it's a luxury item, on the other hand, if you raise the price, I might just decide I don't need that so much after all. How broadly or how narrowly is the good defined? If all I need is shoes, any shoes, I can just buy whatever I buy over at Walmart, and I might be pretty price sensitive. I might tend to look for the lowest price. On the other hand, if what I want is a beautiful pair of Jimmy Choo pumps, those are very specific, and they're very rare, and they're very pricey, and I'm going to pay that price. I'm not going to be price sensitive because I want this particular item. And last, time horizons matter. If the price of gas jumps to $5 a gallon this afternoon, I'm going to pay it. I have to get home from work today, right? That goes back to gasoline as a necessity. And it goes to, I don't have a very long time horizon. That's this afternoon. If gas stayed at $5 a gallon, over time, I would figure out some alternatives. I would start taking the bus. I would buy a more fuel-efficient car. I would start carpooling. I would move closer to my work. I would find alternatives so I didn't have to spend as much on gas. So let's talk about that inelastic versus elastic in a little more detail. Inelastic demand simply means that the change in price is greater than the change in quantity. Price is going up faster than quantity is going down. That's inelastic demand, and it looks like this. The percentage change in price, in this case, might be 10%, but the percentage change in quantity is going to be something less than 10%. So that the change in price is larger than the change in quantity. Price is going up faster than quantity is going down. So that gives you an elasticity less than 1. And it gives you a very steep demand curve, because remember, price is on the vertical axis, and that's where the big change is in the price on the vertical axis. Quantity is on the horizontal axis, but the change in quantity is much smaller, so you don't get much movement left to right. The movement is in top to bottom. So with inelastic demand, the curve is steep, the demand curve is steep. price sensitivity is low. I'm not going to lose all that much quantity when I raise the price, and elasticity is going to be less than 1. On the other hand, when demand is elastic, it simply means that quantity is falling faster than price is increasing. Quantity is decreasing faster than price is increasing. So if you have a 10% change in quantity, a 10% increase in price, your decrease in quantity is going to be something greater than 10%. Let me say that again. I kind of stumbled over my words. If the price change increases by 10%, price goes up by 10, quantity demanded is going to go down by something more than 10. Might go down by 11%, 12%, 20%, 50%, who knows? But it's going to be more than 10%. So because the change in quantity is greater than the change in price, you're going to get an elasticity greater than 1. Your demand curve is going to be rather horizontal because the bigger change is going to be left to right on the quantity axis, the horizontal axis, rather than top to bottom on the price axis, the vertical axis. Your demand curve will be flat, your price sensitivity is high, and your elasticity is greater than 1. And that's it for today for Dr. Archer's lecture. I hope that you'll join us again next time when we're going to talk about how elasticity relates to total revenue. I think you'll find it very interesting. Look forward to seeing you next time on Dr. Archer's lectures.